So in this lab, we're going to make an actual solution. So we're going to start with some amount of grams of something. We're going to need some water, and then we're going to make a specific molarity. Just like we've been doing with calculations, but now we're going to do it in the real world. Okay, so here's the example we're going to go through for this lab. All right, let's assume that we need to make a 2-liter solution of 0.4 molar sodium chloride. All right, so this is our example problem. This is what we'd be making. And the way that we do this is we need to figure out what we'll need. So one thing we'll need is a 2-liter volumetric flask. And a volumetric flask, it looks like this. Then it has a flat bottom, and it has one line on it. Oh, that looks terrible. It has one line on there, and that one line on it is 2 liters. And you can have some that are larger, you can have some that are smaller. In lab, we're going to use smaller ones. But the only thing that this can do is measure one measurement. And that one measurement for this one is 2 liters because it has a line for that there. And it's called a volumetric flask. This is where we're going to prepare our solution. The other thing we'll need to know is how much sodium chloride we need to add to it, right? Because we know we have a molarity right here, but we don't know how many grams to add, okay? So we're going to calculate that. And you guys can do this already, right? What would we start with if we're trying to figure out grams of salt that we need for this? What would we start with? Over here.
Liters.
Liters. Why would we start with liters?
Because it's 1 unit.
Yeah, exactly. Liters is 1 unit. Grams is 1 unit. So if you start with 1 unit, you'll end up with 1 unit, right? All right, so let's do that. 2.00 liters. Okay, we know liters are going to go on the bottom so that they cancel out. Do we have a conversion factor with liters? Yeah, we do, right? Molarity, big M. Big M stands for moles per liter. So this means 0.400 moles per liter. So we can plug that in over here. 0.400 moles of NaCl. All right, the liters cancel out, which is great. Now we have moles. We don't want moles, we want grams. So you guys know what to do. We would put moles on the bottom. So 1 mole on the bottom of NaCl equals how many grams? Yeah, we need to look on the periodic table, right? So sodium's what, 22.99? Chlorine's 35.45. So what does that make it? Oh gosh, math. 58.44. All right. And now the moles are going to cancel out. Oh no, we don't want to do that. Moles are going to cancel out, leaving us with grams, which is what we're looking for. So now we can plug this into our calculator and come up with our answer, which looks like it needs 3 sig figs. You guys help me out because you have a calculator. What do you got?
I got 46.8.
Yeah, that sounds good. 46.8 grams of sodium chloride. Okay, so any questions so far with that? No, right? This is what we've been doing, right? We've been preparing for this, right? We've been preparing for this our whole lives of this chapter, all right? So now we know how many grams that we need. And again, if we think back to this, we need this many grams. We know we want to make 2 liters of solution. When we do this, we'll end up with a solution that is a 0.400 molar solution, okay? And that's our goal. All right, so how do we actually combine the salts and the water to make this? And of course it's chemistry, so it's slightly more complicated than just pouring them together, all right? So let me clear this off. All right, so now that we know the volume and the mass needed, we're going to measure out the mass needed using a weigh boat and a balance, just like you've done before, all right? Don't forget to tare the whey boat before adding the solute. Okay, yeah, you want to make it 0. You're going to use a scupula to add the chemical into the whey boat. Since these balances go to 2 decimal places, that may limit our number of sig figs, which we'll check that out when we get there tomorrow. You're going to add the solute to a beaker. All right, we're going to add it to a small beaker. How much solution are you going to make? All right, well, in this example, we're making 2 liters, right? So you want to add about half of that, or 1 liter, of distilled water to the beaker. So what you're going to do is you're going to have your salt in here, and then you're going to put in distilled water, and then you're going to use a glass stir rod, and you're going to stir it up and basically dissolve it in a little beaker, all right? Now that's going to be more concentrated than our final product because this is about 1 liter of distilled water. And remember, we're going to make 2 liters of it, all right? Is everybody cool with that? So we're going to take some, we're going to mix it up, let it dissolve. That all of it should dissolve, or most of it should dissolve, but it's going to make it a lot easier for us to get it into the volumetric flask next. All right, so we did that. Mix with a glass stir rod to dissolve. Add this solution to the volumetric flask and funnel setup. So this is our volumetric flask. We have a funnel in the top. We have our solution in our beaker. We're pouring it in. All right, everybody's okay with that? Now again, it's only going to fill this up about halfway because it was only 1 liter. All right. Next up. All right, so now this beaker that we poured the water, the solution into, it's still going to have some chemical in there. So you're going to fill this up a little bit, swirl it around, and then pour it through here. You're basically going to rinse whatever was in here and whatever's in the funnel into here. All right, so you'll rinse it a couple times. Makes sense. So rinse the weighing beaker with more solvent to remove all the solute, and pour the rinse into the flask. Add water until the volume of the solution nears the neck of the flask. So once you get up to about here, you want to stop doing this because you're adding a lot of water, all right? And you don't want it to accidentally go over here. Another reason is you're going to want to put the stopper in here and then flip it a couple times very carefully. Swirl it, flip it. If you're turning it upside down, make sure you keep your thumb on top of this so that it doesn't open. But you can just swirl it. And again, that's just to mix it all up. All right, so if anything didn't dissolve, that'll help it dissolve. Next up, you're going to add distilled water to get it up to the line. I know you guys might not be able to see it on this one, but the line is right here. So they're adding water drop by drop in here to get it to that line. This may seem ridiculous, but it's really important because theoretically, if you go over this line, you can't recover that. You can't take water out of it. So the problem is now it'll be a slightly lower molarity than we're looking for. So theoretically, we need to pour it down the drain and start over. Now we're not going to do that. We're not going to waste it. We are going to, you will start over and do it again, but I will save that because it's perfectly fine. It's just the wrong molarity, all right? But you want to make sure that you get it all the way up to the meniscus. And if this is the line right here, remember the whole meniscus thing? It would kind of like curve down, just like that. So you'd want it to kind of go there. For this, we're going to use those little squirt bottles that have the distilled water in them, all right? So just like we've done before, we'll use that. Get that to the line. We'll put a cap on it, and then this time we'll rotate it. It says inverted at least 10 times to ensure complete mixing. All right, and then we have our solution. All right, that's our solution. Everybody's okay with that? Yeah? Okay, cool. All right, and then we'll use our solution to refill some dropper bottles or whatever we need it for the lab. Now, real quick, while we're talking about this, we said before we needed, what was it, 46.8? I don't remember. 46.8 grams? Okay. So we have our volumetric flask, and then we have 46.8 grams of sodium chloride in here, and then this line is 2 liters. If you were to measure 2 liters of water and put that in here first, and then add the salt to it, what would happen to where the water line is? Would it go up, down, stay the same? It would go up, right? So we don't actually have 2 liters of water in here. We have slightly less because this takes up space. So that's why we have to add the solute to it first and then add water to bring it up to the line. And that's what molarity means. It doesn't mean that there's 2 liters of water in there. It means when you have the solution, its total volume is 2 liters. All right, so that's kind of like the difference between those right there. Does anyone have any questions? Now? You sure? Okay. So we have all this. I'm going to stop recording.